So we're going to be looking at how to add and subtract fractions. This is a very common skill used a lot. And it's not necessarily too difficult. It's just a little bit strange at first, but once you get used to it, it shouldn't be too bad. Basically, when we're adding and subtracting fractions, the rule is that you have to have the denominators of the fractions equal before you can add or subtract them. So the bottom numbers in each fraction have to be the same before you can add and subtract. And then when you do add and subtract, you only operate with the top numbers. So if you have two fractions and both bottom numbers are 7, then when you add them, they're going to get an answer that's also has a bottom number of 7. Or if you have two bottom numbers of, say, 5, and you subtract the fractions, your bottom number is also going to be 5 in your answer. The only thing that you actually ever operate with are the top numbers, or the numerators. Now, the trick is, what happens when your bottom numbers aren't the same? Right? How do you get your two bottom numbers to be equal so that you can add or subtract? And the way you do this is through multiplication. So fractions have a rule that you can do anything you want to a fraction. Let's say I have the fraction 2/3. I can do anything I want to this fraction and still keep it the same as long as I do it to the top and the bottom, as long as I do it by multiplication or technically speaking division, but usually it's multiplication that we go with. So if I multiply, say, the top and bottom by 2, I get the fraction 4/6. And 4/6 is the exact same amount as 2/3. If you type in 4 divided by 6, you'll get the same thing as if you typed in 2 divided by 3, which is what the fraction really means. Fractions are really just division problems. I can also times them both by, say, 10 and get 20/30, which is also the exact same number. It's just in a different form. Having 20 pieces out of 30 is the same as having 2 pieces out of 3. 20 for every 30, 2 for every 3, 4 for every 6, they all mean the same thing. They're all equal. So what we want to do is when we have two fractions that are not having the same denominator, we multiply them, top and bottom, to get them so that the denominators are the same, and then we operate with them then. So in practice, it looks something like this. So say I have 3/5 plus 1/10. Well, again, my bottom numbers aren't the same, so I have to figure out how do I make them equal. So I want to think about what number can I multiply both 5 and 10 into. And I want to try to get it to be the smallest number possible. Excuse me. So some of you might be thinking, well, 20, because 5 times 4 is 20 and 10 times 2 is 20. But you can actually even go lower just to 10, right? Because I can make a 5 into a 10 by simply timesing it by 2. And I can make a 10 into a 10 by simply timesing it by 1 or just by leaving it alone because it's the same thing. Now again, the rule is whatever you do to the bottom, you have to do to the top. So if I times the bottom by 2 here, I have to times the top by 2 there. And if I times the bottom by 1, I have to times the top by 1, which again really doesn't change anything. So this fraction really just stays the same. Well, this one is 3 times 2 is 6. 5 times 2 is 10. So I get this. Now, as I said before, your bottom numbers are going to be the same. Your top numbers are going to change. It'd be 6 plus 1, which gives you 7. So your answer would be 7/10. So you add and subtract the top numbers, and you leave the bottom numbers the same. And again, what you have to do first is make the bottom numbers the same by using your multiplication tricks to get either one or both of them to be altered. So in this case, I only had to change the first one. I changed the 5 into a 10 by multiplying by 2, and then my bottom numbers were the same, and I could go about the problem. And the next one, I don't have that option. I can't change a 7 to an 8, and I can't change an 8 into a 7. So I have to go to a different number. So let's say, well, let's do 7 times 2, that's 14, but I can't do 8 times 8 and then I get to 14. So I'll try again. We can do 7 times 3 is 21, but 8 times nothing is 21. We could do 7 times 4 is 28, but can't do anything times 8 to get 28. 7 times 5 is 35, but that doesn't work for 8 either. So if we keep checking here, 7 times 5, 7 times 6, 6 times 7 is 42. I don't think I can do that with an 8. 7 times 7 is 49. Still can't do that with an 8. So then we get to the end of it is just 7 times 8. So 7 times 8, which is 56, and then of course 8 times 7, which is 56. And if you're stuck in a rut and you can't quite figure out the smallest number, what you can do is simply, let's say I want to change this fraction, which I do, I would simply say, okay, here's an 8 here, in my other fraction. I'm going to times the top and bottom here by 8, because that's the bottom of my second fraction. And for this second fraction, I'm going to look over here and say my bottom number is 7 for this first fraction, so I'm going to times the top and bottom by 7. And this will always get you a common denominator. It might not be the lowest, but it will be a common denominator. So 2 times 8 is 16. 8 times 7 is 56. 3 times 7 is 21. 8 times 7 is also 56, which is good. That's what I wanted. I want my bottom numbers to be the same. So now I go about adding them together. 16 plus 21 would give me 37. 56 plus 56 would be something, but we don't add them together because we don't add the bottom numbers in a fraction. We just keep it the same. And so this would be my answer, 37/56. Again, you do not add the bottom numbers. You do not subtract the bottom numbers. You simply leave them be once you get them equaled. Now, same thing for this. Now, 4 and 6, immediately people think of 24, but there's actually a lower one. In fact, I can do 4 times 3 is 12, and 6 times 2 is 12. So I can get them both to be 12. Now, if you did 4 times 6 and 6 times 4, you'd still be okay. You might have to reduce your fraction at the end, but that still would be a fine thing of doing it. So times this by 3 as well, times this by 2. That way I mimic the top and the bottom. 5 times 3 is 15. 4 times 3 is 12. 1 times 3 is 3. 6 times 2 is 12. Again, I do not subtract the bottom number, so it's still going to be 12. 15 minus 3 is going to be, well, 12. And 12 over 12 is just a solid 1. So again, sometimes you can reduce or take the problem further once you get your fraction, but you have to get the bottom numbers to be the same before you do that. Now again, if you did 6 times 4 and 4 times 6 over here, if you switch this up to be times 6 times 6 times 4 times 4, you'd still be okay. You just have to reduce it a little bit more at the end, and you still get the same answer of 1, but it's still an okay way of doing it. And this one. Now again, people might think, okay, well, 12 times 3 is 36, 3 times 12 is 36, or some people might say, well, 12 times 2 is 24, 8 times 3 is 24, but I can just change a 3 into a 12 by timesing this by 4. And then I can just change a 12 into a 12 by just keeping the same and timesing it by 1. Again, you don't really need to times by 1, but I'm just trying to get there to show why it's not changing. So this would become 2 times 4 is 8, 3 times 4 is 12, and this would become 9 times 1 is 9, 12 times 1 is 12. Then I subtract. Excuse me. So now my bottom numbers are the same. 9 minus 8 is just 1. So my answer is 1/12. So you don't necessarily have to change both. Sometimes you can get away with just changing one. Other times, like this one and that one, you can't. But again, the goal is to get your bottom numbers to be the same. So look at your bottom numbers and kind of run through in your head your multiplication tables and think, okay, what's the lowest number I can multiply these both into, and what are the two numbers I need to make that happen? And again, if you really get stuck into a rut, you can do what we did up here and just simply say, okay, I can't figure out what 8 and 7 are going to be, so I'm just going to simply take 8 and times it by top and bottom here, and take 7 and times it to the top and bottom here. And that will always get you a common fraction. Like, for example, if I have a little side note here, let's say I have 5 over 4 plus 7 over 6. So kind of like this one right here. Let's say I'm having trouble thinking about, okay, what can 4 and 6 make? Well, I'm like going to think, okay, I can't figure it out, so I'm going to simply say, okay, what do I multiply the first fraction by? Well, I look down here, and my second fraction has a denominator of 6. So I'm going to take the denominator of the second fraction and times it to the top and bottom here. And what do I multiply my second fraction by? Well, I take the bottom of the first fraction and times it to the top and bottom here. So I get 5 times 6 is 30, 4 times 6 is 24, plus, not equals, plus. 7 times 4 is 28, 6 times 4 is 24. And then I add them together and I get 58 out of 24, which can be reduced by dividing by 2. So if I divide the top and bottom by 2, I get 29 over 12, which would be my final answer. Excuse me. So again, if you're having trouble, simply take the bottom of the second fraction, times it to the first, take the bottom of the first fraction and times it to the second. And that will get you a common denominator. It will not, you might have to reduce at the end like I did here, but it will at least let you progress the problem. That's it for this video. Hope you enjoyed the video. Have a good day.